Why do astrophysicists? Great question. Alright folks, welcome back to my channel, and today we are going to answer Google's autocomplete questions about space, astronomy, astrophysicists, kind of whatever question prompt I can think of. I just thought this would be a fun way to answer some of the most asked questions on the internet without having to do much work to figure out what the questions are. So, let's go. We got a new thing. Check out the beautiful background that I've got here. What should we start with? Why does space smell like steak is the first one. Well, that has to do with the hydrocarbons. So there is a lot of dust in space, and that dust is made primarily of these big chains of hydrocarbons. I'm not a chemist, so this is a rough answer. Those are very similar to the type of things you might get from like a charcoal grill. So yeah, that smell is just space dust. There's a lot of space dust. You can see it when you look out at the Milky Way. It's that. A lot of it is just like the dust you would find in your own home. But apparently, according to astronauts, it also smells like steak. Why does spacebar scroll down? I'm not qualified to answer that one. Why does space exist? Yeah, nope. Also not qualified to answer that one. I mean, we've got the Big Bang and our current understanding of cosmology creating all of space, time, matter, and energy, but why? That is above my pay grade. Why does space have no gravity? So space does have gravity. I think maybe what this question is referring to is like, if you're on the International Space Station, why are you weightless? And in that case, you are actually, when you're orbiting the Earth, you're in a continuous free fall. So astronauts inside any sort of satellite around the Earth are kind of free falling around the Earth, so you don't have a net gravitational pull downwards. You are kind of in this system where there's no force pulling you one way or another, and so you can kind of float around. There are, of course, tons of gravitational fields in space. I mean, that's what's keeping the Earth bound to the sun. We are trapped in the sun's gravitational field. We are even more so trapped in the galaxy's net gravitational field. So space definitely has gravity, but it's weaker compared to what you feel on the surface of the Earth, and it's not necessarily as directional. Why does space have no oxygen? Because there is no oxygen in space. How's that? Because, well, first off, we have seen oxygen gas in what we call the interstellar medium, the gas that is in between stars. That medium is at really low densities though. So there is oxygen out there, it's just at really low densities, so you can't actually breathe. Most of space is a very near vacuum. There's just not a lot in there. What stuff there is tends to cluster to the nearest gravitational source, like a planet or a star. So that's why a lot of it is kind of empty. Why does space expand? Well, part of it is a leftover expansion from the Big Bang. Big Bang created this outward ploof, and we're still experiencing that. The weird thing, though, is we would expect us to be slowing down over time, right? We'd be losing that push from the Big Bang after 13.8 billion years, but we're actually accelerating. Space is expanding faster and faster, and why is that happening? Dark energy. Dark energy is the term we give to whatever it is that is causing space to expand at a faster and faster rate. We don't have a great understanding of that, I will be honest, but the kind of main model is treating it as a cosmological constant. It is just a property, an intrinsic property of space. Where there is space, there is dark energy, and that energy is causing space to expand. Okay, next question. What does an astrophysicist blank do? We study the universe. That can do a lot of different things. On a daily basis, it varies a lot based on what flavor of astrophysicist you are. So I'm a computational astrophysicist. A quick walkthrough of my day. I usually have some sort of task, either running a simulation, getting the data from the simulation, debugging the run that I thought would work, but it didn't. So for me, it's mostly sitting in front of my laptop, trying to code. That's kind of a good overview for what most astrophysicists do, actually. It's a very coding-heavy profession, but what you're actually coding varies. If you are working with observational data, you could be working on, reducing the images, applying filters, getting them to look pretty, trying to get your science done from them. A lot of times you will be reading papers or writing papers, writing grant proposals. It's research, and the research that you do just varies a ton. What does an astrophysicist make? That's a good question. Let's find out. Okay, well, those are a lot of very different answers. Yeah, there you go. I will say I'm a grad student right now, and so I am paid the absolutely atrocious grad student salary, and that for me is about $25,000 a year, which is not much. What you get paid as a grad student varies a lot on where you go to school and what the cost of living is in that state. So in Arizona, cost of living is kind of lower, so it's a lower salary than most of my other friends in grad schools around the country make. But yeah, it's not great, and there's kind of this general problem in academia of being underpaid. So there you go. Let's get back to what does an astrophysicist? What does an astrophysicist do at NASA? Kind of talked about that. What does an astrophysicist wear? This is a Cattern shirt. That's kind of embarrassing. I mean, I normally wear normal clothes, but today I wore my embarrassing space shirt, so that worked out really well. What degree does an astrophysicist need? It depends on what you want to do. So if you want to be a professor and do research at a university, you typically need to get through a PhD. If you're more interested in going into industry, working for smaller space companies, you can do that with a lower degree. In a lot of STEM fields, there is a kind of pay division based on what level of degree you have, whether you have a bachelor's, master's, or a PhD. You kind of go up in salary with that for like more private industry stuff. So it definitely depends on what you want to do, but I would say if you want to be an astrophysicist, that path typically involves getting a PhD. All right, let's try to get some more specific questions. What do galaxies orbit? Galaxies don't necessarily orbit anything. Typically galaxies are found in gravitationally bound groups or clusters. So groups have a few tens of galaxies and clusters have thousands of galaxies. And we just see matter kind of grouped like this throughout the universe. In those, it's not necessarily that the galaxies are all orbiting one center. They are more just gravitationally clumped together, and they can have kind of random movements in that. What do galaxies look like? Well, there's a lot of different types of galaxies. We kind of split them into two main groups: spiral galaxies that have the beautiful spiral arms like the Milky Way, and elliptical galaxies, which are pretty much just blobs, and the stars in them just move in random directions instead of orbiting one way in a plane. And then you have irregular galaxies, which don't fit into either of those categories. They're usually galaxies that are in the process of merging, and so they make all sorts of weird, funky shapes. What do galaxies contain? So this is actually kind of an interesting question in astronomy, because it is, where do you delineate between a really small galaxy and a really big group of stars? Because we can have star clusters, which are just gravitationally bound regions of stars that can have thousands and thousands and thousands of stars and can look kind of like a small dwarf galaxy. So we typically delineate between the two by having a certain number of things, and the main component is dark matter. Galaxies have a lot of dark matter, most of them, and so if you have a lot of dark matter, you're more a galaxy than a big star cluster. But most galaxies have stars, obviously, dark matter, like I said, and then also gas and dust. Spiral galaxies have way more gas and dust than elliptical galaxies. Ellipticals typically have finished with their star forming process, so all of the spare gas has been used up. So ellipticals are mostly just stars and dark matter. Spirals have more of that gas and dust. What do galaxies revolve around? So in like a spiral galaxy, you're revolving around all of the mass that is within your orbit. So there's the supermassive black hole in the center of most galaxies, but there's also tons of dark matter. There's way more dark matter than normal matter. And then all of the stars that are closer to the center of the galaxy than you are. You're orbiting around all of that combined mass. Stellar. What do stars symbolize? Nope. That's literature. What do stars look up? What do stars look like up close? Well, we have actually gotten really close to our sun, so I can show you images. They look kind of like what you would expect. The thing is, you have to put a bunch of filters so that you're not blinded by that light. The light from a star, like the sun, escapes from the level that we call the photosphere, which is essentially a region where the sun reaches a low enough density that light can kind of escape from it. And the photosphere kind of looks like this. You have sunspots, you have weird flares and stuff coming through there. There are further out layers of stars than the photosphere, but the photosphere is the one that we actually see. What do stars do? Stars are another thing where it's like, how do you define it? But the typical definition is stars are a dense region of gas that have reached high enough temperatures and densities to do stellar nuclear fusion. Specifically hydrogen fusion, which means they can take hydrogen atoms and merge them and turn them into helium atoms. And that process produces energy, and that's what makes stars glow. It's the energy produced through nuclear fusion. So that is what stars do. What do stars orbit? Well, most stars are found in galaxies, and they orbit the center of their galaxy. If you're in a nice spiral, you can think of it as the way planets orbit around the sun. In elliptical galaxies, they're not all moving in the same plane. They kind of have random motions, like I mentioned earlier, but they are still orbiting kind of that central region of the elliptical. Why do astronomers put telescopes in space? So that's a great question. The biggest, simplest answer to that is the atmosphere sucks. The atmosphere causes all sorts of problems for astronomers. Not just because of weather, right? You have clouds in the atmosphere that block the light, but also because the atmosphere is constantly moving and changing, and those changes in the gas in the atmosphere distort the star or galaxy or whatever light you want to see that's coming to you from space. So you have to find a way to account for all of the weird distortions that the atmosphere creates. One of the main ways that we do that is by putting telescopes in really high deserts, like in Chile. Because then you don't have a lot of moisture in the air, so those atmospheric fluctuations can be a lot less severe. But if you put them in space, then you don't have to worry about the atmosphere at all, and all of a sudden it gets a lot easier to see things. It's also worth noting that the atmosphere actually emits light. There are particles in the atmosphere that can absorb radiation from the sun and then re-emit that radiation. So depending on what wavelengths you're looking at, the atmosphere might actually produce a lot of background noise. So in general, it's a lot better to have a space telescope, but it's also a lot more complicated because you can't do maintenance or really touch it the same way you can with telescopes on the ground. Why do we use telescopes? Because we are studying things that are incredibly far away, incredibly faint, and incredibly small. And telescopes are really good at capturing a lot of light from faint objects and also magnifying small objects. So that's why. Yeah. Why do astronomers use light years? Well, we actually use a whole bunch of different units for distance. I don't actually use light years in my research. They are too small of a unit. I typically use parsecs or megaparsecs. A parsec is about 3¼ light years, and a megaparsec is 1,000,000 of those. So you can see why a light year is too small of a unit. But if you're working in like a galaxy or with nearby galaxies, light years are great units, because they are, if we were talking about meters or kilometers, the numbers would be really, really huge. If we were talking about megaparsecs, the numbers would be really, really small. So they're kind of a nice in-between unit for nearby things. Light years are also a great unit to give a sense of scale and a sense of history, because when we look into space, we're looking into the past. And using light years is a really easy way to say, oh, this thing is 7,000 light years away. That means we're seeing it as it was 7,000 years ago. So it's a really great unit for converting between time and distance. Why do astronomers study comets? Because they're interesting objects. There's also the possibility of one hitting us. So that's always a good thing to keep an eye on. But yeah, they're kind of fascinating objects that come from the far, far reaches of our solar system, so we can use them to understand a bit more about what is out at the edge of our solar system. There's also the possibility that certain things like water on Earth came from comets, so we're always looking for traces of that in the comets that we look at. I'm skipping around here because all the Julian date stuff is kind of boring. Why do we believe in dark matter? Well, we have a lot of evidence that there is more gravity in the universe than we would expect given the matter we can see. When we look at the stars and gas and dust and the gravitational fields we would expect them to produce, those fields are way weaker than what we actually observe, which suggests that there is some other type of matter that is creating gravitational fields. And that's what dark matter is. It is matter that we can't see, but we can see its gravitational effects on all sorts of other stuff. So there's so many examples of kind of indirect evidence of dark matter like that. There are people working on direct detection experiments. So far, none of them have been successful, but we're pretty sure that's what's out there. Kind of the other explanation is that we're wrong about gravity and how gravity works, but we keep getting evidence that general relativity is a really good way to describe gravity, so that's not super likely. Why do astronomers use red light? So if you have ever been at an observatory, done any sort of, open space night, you may have been told by the people running the observatory, don't use white light, don't turn on your phone, but if you have like a flashlight covered in red cellophane, that's okay. A lot of observatories are lit with red light, and that's just because our eyes aren't as sensitive to red light. When we go outside and we stand in the dark, there's actually a chemical that's secreted by our brain to help heighten the sensitivity of the rods in our eyes. That chemical takes about 30 minutes to reach full effect. And every time you go back into bright light, you have to start that process over. So we really like to work in the dark to see dim objects, but red light, since our eyes aren't as sensitive to it, doesn't necessarily make us restart that process. So red light is much better than white light if you need to see, but you don't want to not be able to see the stars. Why do astronomers find it difficult? because space is hard, man. Science isn't easy, okay? I'm actually curious what happens if I type this in. What do we get here? Why do astronomers find it difficult to locate extrasolar planets with telescopes? Because exoplanets are very, very small and very far away, and they're right next to really bright objects like stars. So for one, their size makes them pretty much impossible to see, but you also have to deal with the fact that they can be drowned out by stars. So the only way that we can really detect exoplanets is by seeing their impact on the star they're orbiting around, instead of seeing the exoplanet directly. The main ways we do that are either with the transit method or a radial velocity method. Transit method essentially says if you have a planet going around a star and you are observing there, when the planet comes in front of the star, it's going to block a little bit of the light from the star. And that star's brightness is going to dip, and then it'll go back to normal as the planet goes behind, and then it'll dip again, and then dip again. And so we get these light curves, and we can see there's something passing in front of a star over and over again. It must be a planet. The other way you can do it is if you have a really massive planet, it actually gravitationally tugs on the star. And so as the planet goes around, the star will move back and forth, and we can detect that red shift and blue shift that will tell us there's a planet there. Why do astronomers find gathering evidence so difficult? Well, because we're working with data that we can't touch. Like, we can't go to Andromeda, ever. So we have to find ways to kind of indirectly figure out what's going on in the universe. Simulations are a really great tool for that. Better telescopes are a great tool. I mean, it's kind of amazing how much we do know about the universe, considering that this is a science where we can't touch most of the stuff that we are studying. All right, I think I'm gonna cut it off there. So I hope that was kind of fun. I enjoyed it. It's fun to see, what people are Googling, what people want to know about space. The fact that I'm wearing the Cattern shirt for that question was a little embarrassing, but it's actually, you know what? I'm owning it. This is a great shirt. It's an objectively fantastic shirt. As always, if you like this video, press that like button, press that subscribe, press the bell for notifications. Am I doing this right? Am I doing the YouTube thing right? I think I'm doing the YouTube thing right. And I will see you next time.